was supposed to do this. Sorry, Casey. If this recording session slows down things, I may just cut it. The second thing is that there are some odds and ends that we need to cover for final project related to the software engineering component. You clearly need to know FileIO. So I consider FileIO as be fairly straightforward. So I'm going to give you some examples today. There is UML diagram. That there is a software I'd like to recommend, although if you're working in Windows environment, Mac environment, there may be additional other software that will help you create the UML. And once you know those two things, the UML diagram, I may not be able to do a whole lot with it today. I may wait until Wednesday to actually demo it, or I may just, since it's just a software, how to use it, I may just create a video of it and put it on YouTube, and you guys can look at it. There's a ton of documentation on the subject anyways. So before we go forward, any questions, comments? This part of the assignment is going to be due next Wednesday, did we say? Or what did we say? So this particular component of the assignment needs to be done by next Wednesday so we can look at it, or maybe just, I mean, I don't really care. As long as it is, as long as I have it before you guys break for Thanksgiving, I'm okay. So it's up to you guys what you want to do, right? Casey, am I speaking on your behalf too? Or, I mean, you can do your class separately than mine. So here is where we are at. We have approximately 2 weeks before school breaks. So if you can give it to me, when do you want to give it to me? What I like to do is between now and before the end of the semester. So after you guys come back, how much do we have? We have this week too, right? The last week of November, first week of December. Is that okay?
Monday, 23rd.
I'm sorry?
Monday.
But that's like reading day, that's like something, right? December, what, 5th? Is that what it is?
So wait, Monday,
21st.
they're saying 21st for the requirements document. That's right before they leave.
You want to do that?
The 9th is the day that they technically would have their final exam. So I was going to have the final implementation.
That's right. So the final implementation needs to be turned in at the time of your scheduled your final exam. So I can't delay that any further. That's bursar office says I can't do anything with that. So it's up to you guys. If you want to do December 21st, you can. November 21st is also when we're going to have the next midterm. So you guys are okay with that? All right. I mean, I'm going to set it to November 21st. Whoever wants to submit it sooner, do. I just need to have it in time so I can look at it, come back with comments over Thanksgiving. So after you come back, maybe we will have some intelligent comments. Yes, Chris.
You're saying just the documentation to
The documentation, this part of the assignment, part A, that I'm going to go over is going to be November 21st. Yes?
Regarding the final due date project on December 9th, you said it could be after the final exam day. I was wondering what effect the time of day comes into play, because you currently have it set for 12:55 p.m. that night.
Right.
The final is 12:30 that afternoon.
That's right. So it needs to be, everything needs to be reported turned in by the exact end of the final exam time. So if exam is what, 12:30,
12:30.
and you have 3 hours, so
2.5 hours.
2.5 hours, so 3 o'clock. Okay, so final project is assembly of sequences. It doesn't really matter whether it's biological sequences, whatever sequences. We're going to put some example data up for you guys to look at it soon. And I'm going to make it very simple, straightforward, to a little bit more complicated that you can't just eyeball it. So the whole general idea here is to familiarize you with the process of software engineering. And most of you could have probably benefited from this before you come to this class, because you go, I don't know what your experience was in 145, 146, so suddenly you find yourself facing development of a software that it just doesn't fall out of you, so you need to put some thought into it. You need to think about it, how you would solve it, what kind of program you would need to write, what is the core solution that you need to put in place and from there proceed forward. So I think you would have all benefited from that, but it's not in place. So background. Casey, do you want to conduct this part? Would you be able to do this? You probably will do it better than I can. Let me say my piece, whatever I can, and then you can probably fill in. Yes. No, I mean. It's what? This is in pairs. So from this point, this part A and part B of this assignment is going to be in pairs, which is going to be part of what you need to specify in your document as to who are the team members. So there are some components here missing. We were talking, Casey and I, we were missing. We need to include it, and that's the part that I need to add. Basically, you need to provide a documentation where you might want to just look at this. Description of the problem so that we are both clear of what the problem is. And you can, if you like, really the idea here is that you can treat it as I'm a client, I need some programming expertise, and I'm coming to you and I'm saying, I need you to recruit your expertise in writing a program for me. All right? This is really to proceed and work within that context. And to further complicate or be realistic, I know very little about programming. I just know about my problem. You can probe me all you want about my problem, but I have no idea how to solve it. In this case, that's not the case. But that's essentially what we are trying to do. So a description of the problem such that in a report that you give back to your client, you're clear as to what the nature of the problem is. Overall description of your solution to the problem. So what is the general idea? How are you going to approach this? And we have kind of like I talked about it last time when I was presenting. The general idea is to overlap the sequences based on 20 characters at the end of one needs to match the 20 characters at the beginning of the one, and you need to proceed that way. So that solution is kind of simple for now, at least. If anybody's interested, I can maybe towards the end of the semester I can put you more complicated versions of the problem. The use cases for each user use cases for each user interaction. Is that? I think it's useful here because. Okay, so I envision your program is going to gather its information through the command line argument that you're going to, for example, say, here's my input file, this is the name of my output file, and I want 20 character overlap, which can be a parameter that's going to be passed.
So use cases.
Is it more?
Yeah. I mean, basically, you're going to try to capture how the user would interact with your software. So you'll have one where it's the ideal situation where they use the software exactly as you want them to, but then you also need to figure out, so if they enter something that's not a correct parameter, what will your software do? Will it submit an error? Will it prompt them again? Will it tell them, how to use your program? So that's kind of the idea of like a use case.
Okay.
And then test cases, which are one further down. You need to test each use case. And so now you have your use cases, and so now you go maybe based on ideal that they give this data and it comes out perfectly. It comes out as expected, and then they give this specific, input, and it comes out this specific way to test your data to figure out if things are actually working.
You will become more familiar with these terms. These are actual terms that are used in the realm of software engineering after Dr. Gay's presentation on Monday and Friday and Monday. But in essence, that's what we are talking about. So use cases is that how is a program, like it makes more sense when you were to put a GUI together, where the user is actually interacting with the software and there's a continuous interaction kind of a thing. In our case, much of this kind of falls apart. And you'll see a number of instances. So a use case is going to be simplified. For example, is going to be if the information is going to be passed to your program through command line, then in case that the right arguments are not passed, the program is going to prompt the user or is going to give a usage information as to what should be used. In case, like for example, in the case of when we were developing the string class, in the case that you were exceeding the boundaries of the array, we decided the program would just exit. So those are some of the things you might want to explore under unforeseen or under some rare conditions. How should the program behave? test cases becomes critical from my perspective. And in this particular assignment, you should actually take good use of it. Now, many of you I have seen, not just you guys, I'm just kind of referring to you guys as well as the past classes as well. You write a program, you compile it, you run it, and if it gives you the numbers you're looking for, you declare it done. So it's clear, hopefully at this point, you need to expand your horizons beyond that. The program needs to have no memory leak. Remember in C++, under some conditions, the program is going to run perfectly fine, and you take the same program and put it on a different machine, doesn't compile, it may compile and run and give you segmentation fault. You come back the next day and you run the program on the same machine and still was working perfectly fine yesterday, but today, for whatever reason, the program fails. So memory allocation components need to be tested. Now, you need to come up with simple case. This is easily a type of an assignment that you can completely get lost in what the output should be. So you need to start with a simple case that you're going to test it by taking something like a small set program, a small set input data that you can visually confirm what the output is going to be. How are you going to test your software to make sure that it is working right? If I were you, I would, for example, propose that you are going to prepare your own set of data. You're going to take a chunk of a string, break it up yourself, and since you know they should assemble to become the final string that you started with, then you're going to do it that way. You're going to make sure that you're going to be able to recreate the original string. So, and we'll see if we can help you on that case too. Your time complexity prediction, remember we talked about this. I just need you to put some thought into it. Where is going to be the biggest chunk of your program that is going to take execution time? And what is the nature of that particular part of your code? Usually it's like if it is two nested for loops, it's order of n squared complexity. If it is a single for loop, it's order n complexity. So put some thought into it. It's not important for you guys to be right. It's more important that this to have some sort of an intelligent guess, followed by how would you go about testing it and confirming or rejecting what you had proposed. UML diagram. Did I say anything about UML diagram? UML diagram is essentially a way that you can, remember we created a .h file and a .cpp file where .h file talks about what methods should be in place, what should be the member functions, what should be member data, what should be the attributes of the functions, what does it take, what does it return. All that information is encapsulated in .h file, and the details of programming is in .cpp file. So the UML diagram also shows inheritance of objects, how objects relate to each other. If you have two classes, what is the relationship that they have? So UML diagram basically encapsulates and quickly visualizes all of that. I'm going to go into this, probably dedicate maybe portion of lecture, either video, put it there, or demonstrate how it might work in maybe the Wednesday class. So you're going to create a visualization of your software, what members it has and how it interacts. Your program needs to show one instance of inheritance. So from the programming perspective, I need you to demonstrate inheritance. You are not to use a string class that comes with CPP, with C++, you're not to use vector class. So everything that you're writing is your own writing. I don't want to turn this class into go and hack and search Google in order to write something for you. This is an exercise in programming for yourselves. So again, the proposed approach that I had suggested was you start with your string class and inherit from it to be like a genome class, and genome class then inherits all the capabilities of string, limits in the characters what they can be, and maybe adds methods to it that well then assembles sequences together. And that's where the core of your solution comes in. And I'm not sure, Casey, we may provide you, Dr. Gay has actually a number of templates for creation of these things, and we're going to put examples of those templates so you can use it as a starting point. Casey, you want to comment on any of these?
I think
What are
there's
these?
just an example use case, and then there's a test case for that use case. thinking about it, they'll probably only have like one, maybe two use cases, but they could have several test cases.
Yeah, depends on what you're proposing to do. So if you really want to take on a bigger project,
Yeah, I mean, for instance, if you were going to take on the one where you want to run them in parallel, one use case would be running them without parallelization, and
Exactly.
then the other one would be with.
Yeah,
That
so-
could be some flag that you send to your
Right.
program and say, use it in parallel or don't.
right. So we can talk about how you can make this program more complex later. Something that we have contemplated, and I'm not sure, I'm going to have to look at whether I have money or not. If I have money, I would pay for an award for the top some number of programs.
That run the fastest.
Money,
And
guys,
give the
money.
correct results, to be clear.
It may not be cash. That may sound a little bit fishy.
Yeah, it might
But
be a gift card.
I may be able to like give you a gift card, or I may be able to give you a smartwatch.
Challenge accepted.
Challenges. So anyhow, I know you have a lot of questions about this. I'm happy to answer some of them now, but some of them I'm going to defer until later after having listened to Dr. Gay's presentation on Friday and Monday. And at that point on Wednesday, we can talk about it more. Speak your minds.
You don't need us to format the written part anyway, right?
I mean, it would be useful to have it in a coherent fashion, but what we're going to do, we're going to give you a template that hopefully will have these sections identified, and you can just fill in the information. Okay. Yes?
So will there be a separate Dropbox for the documentation part?
There will be two different projects, basically. Yeah, there will be Dropbox submission that's due November 21st for Part A, and
And what's the time?
I put 11:55, November 21, unless somebody wants it differently. Okay, so there are critical parts that I need to kind of start pissing and moaning about. So I give a team project because very likely where you go to write programs, you're going to work in team environment. In the class, how it turns out is that students pair up on the basis of really strong students pair up together, and the weak students go and somehow find somebody who's going to do their work for them and basically never get the work done. And there is really no way around it. People are usually nice enough that they don't come and say, hey, somebody else did all the work. But I'm going to give you an opportunity that if you feel, so you have to be bound by your own personal work ethics. If you feel somebody's not doing their job and your program suffered because of it, your grades suffered because of it, I think you should be able to speak up, at least if nothing else, not to get the other person in trouble, but to recover the points that you deserve. Since it's a team project and you don't know how this is going to pan out, your team member may never show up, in which case you're kind of screwed. You either accept a really bad grade or just step up and do the entire thing and just not worry about the whole idea of teamwork. So as part of the requirement, what we're going to do, you need to disclose, it's not in here, but I'm going to put it in here. You need to define the team members and define the team member responsibility. So on the project that you lay out, in the programming assignment that there is, what is what is each one of the members going to do? So that needs to be clearly defined. It's not sufficient to say we will collectively do the work. That's not good enough. And then in the final project, Casey suggested this, and I think it's a great idea, you evaluate your teammate. And that will be an opportunity that you can come back and say, Bum never showed up, Bum never did anything. I did my part compiles and runs, the other part doesn't. So we can actually recover and independently assign grades. Any concerns, any comments, please come back to me, let me know what you're thinking, and we can go from there. FileIO. Just crap, every time I do this, I forget how I did it, and tools window, window. Can you guys see this, or is it too small of code? What are you guys in the back? Can you see it? Or I'm happy to enlarge it. You just need to bear with me to stumble around and see. Whereas somewhere in here there's a preference, and in that preference, some weird place, you get to indicate what your font size should be. Source maybe. Yeah.
Alt zoom.
What is it? It doesn't.
Instead of control zoom, do alt zoom.
I mean, what is zoom? Plus?
Or alt, like mouse wheel.
I'll do it. Will that do it? Okay, that's not gonna do it, is it? Wait, hold on. I don't like that. It's there. Lots of color. Default. Let's see. Okay. So this is a program I have written from the past, and I'm just going to go over this, and I'll put it on the web. So remember how we were talking about when you were overloading the string insertion operator cout, you defined the type of object that gets passed in was an output stream. So this is along that line. So the inheritance is that you have input stream, output stream. These streams can be from files or other devices. In this case, it becomes a specific case of an input stream that's F. So IF stream is an input file stream. OF stream is output file stream. So these are the direct mechanisms of interacting with files as a source of your input-output. And if you recall, going back to the beginning of the class, all the assumed CIN and COUTs, they work with standard input, standard output. Standard input being your keyboard, standard output being your screen. And what we want to do, we want to just gradually shift so we formally perform FileIO. There was that redirection that we kind of did, but redirection was a hack. So in FileIO, there are a couple of things that you need to do. There is a file name. That one we are kind of at ease with it. But there is also a file handler that usually in all programming languages in place, but most novice users kind of begin to lose sense of what it is and what it is for. So in this particular case, input file names are going to be of the type string. In this case, I have input. It's going to be the name of the file. This is when you go do an ls, but this is when you look in the file manager, you see the file name. That's what that input is going to be. But the moment your computer, your program, opens that file, it needs to have a handler. That file handler at that point is going to be used in order to do all the transactions with that file. Now that file handler, an example of it was CIN, an example of it was COUT. In this particular case, we're going to create our own ones. So to go over it, and I don't really need this either, so let's just new call it out. So this portion of the code is to just refresh as to what argc argv is. So this is the place that argc argv comes in handy again. So argc, remember, was what? We went over this, right? So argc reports what? How many elements are in your command line argument? So if I say a.out versus a.out, I don't know, input.text, what is the argc here? What should be the argc that I read here? What is the argc that I read here? So for this one, argc is going to be 1, indicating that this particular command was consisted of one element. In here is going to be 2, because there's an a.out followed by another argument. And the separation of argument is always white space delimiting. So if you manage to do this, and these are the kinds of things that I personally have done before, input followed by a space txt, and I specify, I denote space by just a blank here. So I accidentally sometimes I type in, instead of putting a period, I press space bar and I type this in. So by mistake, what would be the argc here? Well, it would be 3, right? Because it takes the space to basically, then there's 3 arguments. You're going to use this counter as a way of seeing if the right appropriate number of arguments have been passed. So the right way to do this, and this is part of your, use case? Use case is that if your program requires to have 3 arguments, you need to specify what those 3 arguments are. It's not just enough to check for the right arguments, but if they're not there, you need to actually help the user to see what is it that I should put as my arguments. So you need to have a usage. Here, I'm checking to see whether I have 3 things being passed to this program. And I actually don't know what this program does, so this will be a good exercise to look at and see what it does. It should be straightforward. So if the program does not have 3 arguments, then it's going to print out usages argv0. So the moment you have argc, then all of these components are going to be in a form of a character string. So argv0 is going to be this guy. The next one is going to be argv1, and this one is going to be argv2. So now you can access, you know that there are 3 things in this command line, and you can access what the first one was, what the second one was, what the third one was, and all of that is encapsulated, captured in argv argument. So you can go through the way that it should work. Usage, argv0 is always the name of the program that's being executed, a.out. And from that point forward, it requires an input file name, and you need to give it an output file name. So this program, the proper usage of it is to type in a.out followed by a name of an input file, followed by name of the output file, and at this point the program exits. If it has the right number of arguments, then it proceeds forward. Are we good so far? So this is something your program will need to implement. Go forward. Come on, guys, wake up. Thanksgiving is around the corner from their Christmas, and then you'll never see me again. C++ is a thing of history. You'll never program again for computer scientists. Yes?
Will this be on GitHub?
I'm sorry?
Will this be on GitHub?
This particular program? Yes. It's not yet, but I can put it there. This is nothing of spectacular importance. But so the moment you want to officially open a channel of communication to any file, you kind of need to execute almost this block of code. And this block of code kind of is like similar for almost all FileIO. And there are multiple number of ways you can do this. So this is the way that I like to do it. You can just adopt this as a starting point, and then you can inject your own kind of personal style. So argv1, remember, was the name of the input file. argv2 was the name of the output file. So the first thing that you want to do, you want to infile, which was an input file stream. So let's keep track of that. Infile is an input file stream type. Output file is an output file stream type. Now, these are objects, so therefore they have their own methods, including open. So you're going to say infile.open, and you're going to pass the name of the file that you want to open as an input stream, input file stream. And you're going to check to see if the file opened or not. So even though under the right circumstances the file is going to open and work, this particular if statement is not required, but this is again part of the use cases, right? So what if the file that you are trying to open is not there? What should the program do? So in this particular case, the program tries to open the file name that's given. If it fails, then it's going to tell you couldn't opening the file didn't work. It just tell me that something about the input file is not there, something related to input file, and at that point you can exit. Otherwise, if it didn't fail, you go to second step, which is open up an output stream using argv2. Again, you open the file and you check to see whether it is it failed. If it failed, you're going to issue some sort of an error saying output file didn't work, and you can exit. Of course, these parts of it, you can make it far more sophisticated. This is the part if your program was GUI, had a GUI, you could explore the possibilities as to why the file didn't work. This is the part that you can make it complicated and say, re-prompt the user, input file didn't work, give me another file, work until it works. I'm not too interested in those. I think you can do those fine. Those are just a couple of for loops, while statements, you can write functions around it. I'm not too worried about it. But the more important question, why would this happen? Can you please highlight the reasons why the file would not open? Give me stuff. Some of it is obvious. Yes? It does not exist is one example. The file name that you were putting, you kind of screwed it up like this. You put a space in the place of a dot. The file name input doesn't exist, so it doesn't open it. File doesn't exist. File may exist, but there's nothing in it. Is that an issue at this point as far as opening it? No. It's not an issue because you haven't read it yet. You just open the file. File exists, you can open it, but you haven't read anything out of it yet. Other issues that normally people who are not in the world of system administration, they don't think about it, is that in Linux, you can associate privileges with the file. That a file may exist, but I as a user do not have privilege to open it. So that could be another cause, that the file is not readable by me, therefore I can't open it as an input file, or I don't have write privileges, therefore I can't open it as an output file. If I have read access, I can open it for reading. If I have write access, I can open it for writing, but I cannot open it under the intention anything other than what my privileges allow. So just be careful, cautious. Usually this kind of stuff you guys don't care about, but these are the test cases. This is how you test whether you have reached the end of file, okay? So, by the way, so the moment you have opened the file where you use the actual file name, input.txt, whatever sequences.txt, at that point forward, that name disappears in your existence of your program. From that point forward, you interact with that file only through the file handler, which in this case is the in file or out file. So the way that you know whether you have reached the end of file or not is this. While not in file.end of file, EOF is end of file character. Well, while you have not reached there, you loop through and do something useful. And in this particular case, get line reads the entire line of sequence, everything that's in one line, and puts it in the string input. And you can turn around and print that input. I'm not doing anything other than read it, write it. So it's really not doing anything useful. You guys will implement something like this. You write an entire sequence and see if you can assemble anything around it. So this part of it is going to be beefy but hidden. Okay? By that I mean you are probably going to have a genome class. You're going to instantiate an object called genome. In this particular case, you say whatever genome dot append and give the string, and that object is going to decide whether this is something that it can incorporate into the string or not. So it's hidden from the user because all you do is just say assembly. But of course, you are responsible for writing it. Therefore, it's really is behind the scenes of the object. And once you're done doing everything with your files, you properly close your files. So input file and output file, you close them in order to have coherent files. And So that's it. From this point forward, all I need to do, I would like to do, is just tell you a few odds and ends that probably as programmers you don't really care about, but as knowledgeable people who are literate in the world of computer science, you kind of would like to know. But I'm going to stop. Do you have any questions so far? Straightforward. You input, you declare your files as input streams or output streams, and then from that point forward, you can basically use the program. Now, note that in here, if I had replaced C out instead of this out file, everything would have just gone to the standard out and be echoed to the screen. So it's the exact same syntax, but now I can just write to the output file. Yes?
Could you explain the while one more time?
Sure. So basically, what you do have in your file, let's say my file is my name. I have a file. So this is myinfo.txt. This is a file that when I open it in some sort of an editor, all I see one line, and this is all it is. So the program is going to, what I wanted to do, I wanted to go read it one line at a time and do something useful with it. So it's reading the inside of the loop is basically saying, get a line and put it in a variable input, which is a type string, and take that and echo it to another output file. So the inside of it is just read a line, print a line, read a line, print a line. But I want to know, where should I stop? So I read that, I'm good. I read this, I'm good. But then, so every time this file handler basically has a pointer that is pointing to how far in the file it has read and how much more information that there is. At the end of every file, there is some sort of a hidden character that signifies end of file. It's invisible character, you can't see it, but it is there. So as this program points to something that's not in the file, remember there was that \0 in a case of a string that would signify the end of a string array. This is the same exact principle. There's a hidden character, invisible, at the end of every file that specifies this is the end of file character. So in all of the programming languages that I have ever known, it's called EOF. Sometimes it's capitalized, sometimes it's small characters. EOF, end of file character. This file pointer always points to where it is reading. It will advance every time you read a file. So you read my name, Homayun, then it hops to the next one. It's pointing to something that's not in the file, so read this. So then the next iteration will be pointing to end of file character. So when the while loop is executing, when your file pointer is pointing to the end of file character, then it's going to know that's the end of file. There is no additional information in there, and it terminates. This is how your file system knows where's the end of the file. Like in Windows operating system. Okay, so forget that.
Control-Z.
What is it?
Control-Z.
It's Control-Z, and if you go in here and nuke that, you're kind of screwed, because your file, the end of file is undetermined anymore, and it runs into the next file that's in the sequence of your file system. So you can corrupt your system. Yes?
What's causing it to jump down each line?
So every time you do a read, so the way FileIO works, every time you do a read, this handler advances one character at a time. So in this particular instance, we are reading a line at a time. So it grabs this entire thing, and in fact, if you dig into the specifics of it, let's not dig into the specifics of it. You can do this. You can just read it one character at a time. So it points at the beginning of the file. You read it one character. After it successfully reads it, it advances the file pointer to the next one. It advances it to the next one, next one, next one, dot, dot, dot. It reaches \n. It advances to the next line, and so on. So it reads really one character at a time. If you look at getLine function, it reads characters at the time until it encounters \n, and then it stops. It doesn't read anymore. So this pointer, file pointer, advances every time you go forward. And this is a sequential file system. It only goes forward. You cannot jump to character number 58. If you want to jump to character 58, you have to perform 57 reads before you get there. So this is a sequential file I/O. You can go from beginning to end only sequentially. You cannot just arbitrarily jump to a single place. Now, the moment you get to the end of it, if you want to start over again, you have to manually set this pointer. You have to specify .seek file pointer 0, then pointer will go back up there. So you have full manipulation of this thing. You can get to the end of it, jump to the beginning again, and so on and so forth. You have full, complete manipulation of this file pointer, but that file pointer points to what is the next thing to be read. And when it gets to end of file character, it points to a character that's recognized as end of file. So in fact, that while in file, that end of file, it looks at the current character to which you're pointing. If it is Control D, whatever your file system is, the appropriate end of file character. If it is pointing to that, it's going to come back as a yes. So while you're not pointing to end of file character, it's ready to read more. So there's FileIO. Yes.
So if you don't put the in file close, out file close, is that just like a memory leak? Or?
Yeah, so let me actually, I'm going to comment on that. That's a good question. Let me, hold on. What you got? Same thing.
End of files or else is it already just like in C++? There's no.
It is operating system specific. So when you, for example, download C++ for Windows, download in C++ version of the, and the Windows specific version of C++, the end of file character is defined what it is. So it's operating system specific. Back to your question. So these two statements, one time when I was a graduate student, we had a competition similar to what I'm basically proposing. And all the people who could have sorted, I think it was 1,000,064 bit numbers in less than a certain amount of time, 10 seconds or something. The top 10 people would collect their programs and basically publish a work and get a publication out of it. So it was a big deal. It turned out that one dirtbag managed to cheat and get into the list of 10 people by simply excluding formal closing of the files. So he would open the file, he would read them, he would sort them, but he would never close them. And these are actually relatively costly operations. They cost a good amount of time to close a file. And what you do then, there is some sort of transaction and negotiation goes on between the program and the operating system. And the program is going to say, okay, I'm done. I want to close my transaction with this file. Aside from the variable that is the object that is actually in file and out file, aside from the object that needs to call its destructor and be released to the operating system needs to go back to its file system and where appropriate put this Control D in there, or whatever the end of file character is. And it needs to make sure, what if you just don't have space to put this one last character? Then it's kind of screwed, right? What if this one last character is right at the beginning of the next file? They're just right back to back, you just don't have any more. Then what do you do? Then in that case, what the operating system does, it takes the chunk that it just wrote, moves it somewhere else that it does have room to put that one last character, puts it, and formally then closes the file. Now, I don't know if you guys have ever done defragmentation of your partitions in your Windows environment, that you go and suddenly crap is all over the place, and after defragmentation, everything packed nicely. Some of it is because of this issue. So when you are creating a file, if you don't do these, chances are you're going to be okay, and the operating system is going to then insert it for you. But chances are, especially in the cases that you're writing into an output file, if you don't do this, you totally screw up your operating system. And then next time you get in there, your files are corrupt, crap is not there. And if you wanted to tinker with somebody's program, this is the way. If you want to really, you're doing some illegal things on your hard drives, you want to make sure that it is nuked. You open up your file from the beginning to end, you just write zeros. 0, 0, 0, 0, 0, right over everything, and then terminate and be done. At that point, data is not recoverable anymore. You're done. Then you can do whatever the hell you were doing. Okay, I'll put this on on GitHub. See you guys.